So elementary algebra 3.2a. Now I know this is going to be at least 2 videos, possibly 3. This is kind of a long section. And this is called graphing linear equations in 2 variables. Alright, so in the last section or so I was talking about how a graph is a picture of an equation. Some of the pictures of equations, if we have a graph like this, the xy axis, some equations are going to draw pictures like that. Some of them are going to draw pictures like that. I mean, there's just all kinds of crazy graphs or pictures of problems that you can get in your equations. But right now, we're going to go boring with all of the graphs that we get looking like that, a straight line. And that's what we're going to stick with. That's why they're called linear equations, because the picture of these equations is a straight line. Okay, so that being the case, let's go ahead and get started with some preliminary stuff. At this point, when we were drawing graphs of equations that looked like this, okay, and maybe this will help you to understand what's going on a little bit better. We have one variable, an x. Now sometimes that variable may occur several times in a problem like that. It occurs here and here, but it's still only one letter. Alright, it's the same letter. So when a variable occurs once, you can graph it on a number line. How many number lines do I have there? I have 1. When we have an equation that has 2 variables, like 2y, I have this graph, but I also have this number line here. So I have 2 variables, I have 2 number lines. And this is the one that we're going to focus on today. Imagine what would happen if we had 3 variables. Then we've got 3 lines, and actually this is a freebie. You've got the x-axis, the y-axis, and then the z-axis, which goes through this point and comes straight toward you. And that gives you a 3-dimensional object. We're going to stick with 2 dimensions. 2 dimensions means there's a length and a width, or a length and a height, or something. So at this point with this xy axis, we go over and up. We go 2 different directions. We've got a dimension this way and a dimension that way, and that's why it's called 2-dimensional. And we have an x and a y. So that's what we're going to be working with today with this lesson, is the x and the y. Alright, so let's put an equation up here. We have 2x plus y equals 3. So how many answers do you think there are to this? How many numbers can we put in for x and then y in order to take 2 times a number plus y and get a 3? Well, we could put in 1 for x and 1 for y and get 3. What if we put in 2 for x and negative 1 in for y? We also get 3. So there are several different answers that make this a true statement. In fact, if you've ever seen this symbol, oh, that's a terrible symbol. That means infinity. That means there is an unknown amount. There is forever amount of numbers that will make that statement true. And the way we show that that statement is an infinite amount of numbers is we show a graph. And let's say we put the numbers that we found on the graph. 1, 1. There's 1, 1. And then 2, negative 1. Okay? And if we connect these dots here with a line, every single dot on this line, every point on this line, no matter where we stop along the line, if we take the 2 numbers, so again, it's 2-dimensional, so there's 2 numbers to represent this point. So let's say we take this point right here. Let's put a little circle here. Let's say we take that point. And that point, whatever it is, we take the number from the y-axis over, or I guess I should say, let's do this in yellow here, you can see it better, from here That's our x. That's how far we went over x. And we put that number in for x here. So 2 times whatever number that is, however far it is from there. And then we go down, and that's our y. And since we went down, we went a minus direction. So when we put that number for x, the amount we went over, in here, and the amount we went down in here, this will be a true statement. Because every point on this line, the x, y value, we put in here and here, just like, we put these in, that will make a true statement. And so there's an infinite number of points that work. Okay, so it's not just one point that works, it's an infinite number of points. So, all that to say, let's go ahead and do some practice, and if it's a little abstract and you're like, I have no idea what he was just talking about, maybe some of these examples will help make a little bit more sense to you, I hope. So, let's go ahead and get started here. So it says, which of the ordered pairs, 2, 3, 1, 5, -2, -4, are solutions to the equation y equals 3x plus 2. Now, just because there's an infinite number of solutions doesn't mean that each of these 3 are part of that infinite number of solutions. So let's try them. So what we do here is we take the y value, the second number is always y, and we put it in here. Then we take 3, and we take the x value and put it here, and see if that is true. Okay? So, does 2, 3 work? Is 3 equal to 6 plus 2 is 8? No, it's not equal. So those don't work. Alright, let's try 1, 5. So we're going to put 5 in for y. And make sure you put the right number in for the right letter. First number is always the x, so that's always the x, and that's what we're going to put in here. Plus 2. Is this, whoops, is that a true statement once I get my equal sign in here? 5 equals 3 times 1 plus 2 is 5. Okay, so -1 or 1, 5 works. Let's put a box around there just so we remember where it is. -4, my y value. Why do I keep putting a comma there? Equals 3 times -2 plus 2. So -4 equals -6 plus 2. So -4 equals -4. Okay, so this works, 1, 5, and -2, -4 work. But this one did not work. Okay, it was just some random number out in La La Land somewhere that we just stuck in there and it didn't work. Okay, so example 2 is a little bit different. They don't give us everything. They give us one part of the point. They give us, sometimes they gave us the x, sometimes they gave us the y. Okay, so they're saying here, find out what number goes in here for y, given that x is 0. Alright, so we find 2, put 0 in for x. We don't know what our y is, that's what we're looking for. So we're going to do this just like a regular algebra problem. 2 times 0, any number times 0 is 0. So all we have is 3y equals 6. Divide by 3, divide by 3, y equals 2. So when x is 0, y is 2. So we're going to put a 2 in there. Okay? So that's what they're asking you to do. They're asking you to find out what number is, let's see what happens there. That's not what I wanted. Okay. So now let's look at this one. So we have 2. We're trying to find x now, and we're given the y value. The y value is 1. Okay. -3, -3. So 2x, and those go away, equals -6 minus 3 is 3. Going to divide by 2, so x is 3/2, which is okay. We can get a fraction for our x value. Nothing wrong with that. Alright, so let's go ahead and do this last one here, and we're going to put a 3 in for x. So we're going to put a 3 in for x, and we're looking for the y value. So I have 6 plus 3y equals 6. Subtract 6, subtract 6. Those go away. We have 3y equals 0. Divide by 3, divide by 3. Okay, y equals 0 over 3. Whenever 0 is in the numerator, the answer is always, without a doubt, never changes, 0. So there are 3 solutions. Okay, so when I draw this graph, I'm going to get 3 dots that when I connect the dots, I'm going to get a straight line. In fact, let's go ahead and try that. Here's my, and it's not going to be exact because obviously my graph lacks being perfect, although it's pretty close. Not really. 0, 2. So let's see, red. 0, 2. 1 1/2. 3 halves 1. So 1 1/2, 1. And 3, 0. 1, 2, 3, 0. Alright, so if my graph was perfect, I would get a straight line that includes all 3 of those points. And if it doesn't go through the points exactly, make your points bigger. Just kidding, don't make your points bigger, but see how it goes through all 3 of those points. It also means that every stinking point along this line will also make this a true statement. So we found 3 that make it a true statement in order to get my line, but if you draw a line, all of the points on that purple line will make it a true statement. So for example 3, this is another way. I mean, before we were doing this, and I would put like a number here and leave this one blank, and maybe put a number here and leave the first place blank. Okay, this is kind of the same thing, doing this little table here. Is example 3, they say, what are you going to get for y if your x is 0, or if your x is 5, or maybe your y is 7 and your y is 3. So we're going to look at this one first. If x is 0, what do I get? Y equals, that is 0, so negative 1. Y is negative 1. So when x is 0, y is negative 1. When x is 5, y equals 10 minus 1, which is 9. So put a 9 there. Alright, so let's look at if y is 7. So we did some x's. X is 0 and x is 5. Now what happens if y is 7? We just plug information in there and we look for the x value. Okay, and then we're going to divide by 2, cancel, x is 4. Okay, so we'll keep going with this. Let's see here. So if y is 3, okay, so we're going to add 1, so I get 4 equals 2x, divide by 2, x is 4 over 2, which is 2. And we put that in there. So what I was doing is I was just filling in the table. And that's all they asked me to do, is in this one, complete the table. So if you're given an x, you find the y. If you were given a y, you find the x. All right, so I'm going to shut this down at 14 minutes, and we will continue with 3.2, B as in boy.